Hey everybody, Brandon here, and it's day 3 of the March Madness Predictive Analytics Challenge for the NCAA Men's Basketball Tournament. So, today in this video, this will be my third and final video on the topic. I'm going to talk a little bit about some data cleaning. I'm going to talk a little bit about some data wrangling, and then I'm going to talk a little bit about some model training, and you are going to walk out of this video with my predictions. Spoiler alert, I'm already wrong on one of them. With my predictions based on the model, not mine, so not mine entirely, the model's predictions for who is going to the Final Four. And I'm going to give you my prediction, which is still relevant, for who I think is going to take the whole thing. Okay, so I have posted in the group guide section 2 new posts under the March Madness guide. 2 code sets. One is March Madness Data Wrangle code set. The other is a March Madness Model Training code set. These are super simple codes that just show you, give you a little bit more insight into how I wrangled the data to get it into a format that is machine readable, machine learning model trainable. And then I also have some really simple code to actually train a model on the data. And then I'm going to show you the results, and we're going to get into my predictions. So with that said, March Madness Data Wrangle, that code set, as I mentioned, it's super simple. It's only about 40 lines of code. I have that down here. Let's go ahead. Here, let's drop the basketball. Let's go ahead and zoom in a little bit. Okay, so what you got here is, you see I pull in NumPy, Pandas libraries. They help me do some data manipulations. Okay, so the goal here, remember, is we first need to create our target. So if you recall in the video for day 2, I showed you the data set. It's also posted in the guide section as well. That training data set has a column in there called Final Four Outcome. And that Final Four Outcome column was created from the Wikipedia website. So what I did was I actually added some additional code to create a classifier with that column, and I am or target with that column, a binary target. So what you see here is a function that says Final Four target. All I'm doing is I am just saying that if that column cell contains a null value, then that team gets a 0 for the Final Four target. That means the team just never made it to the Final Four. For everybody else, they get a 1, right? So all other values. So that means that everyone else has something in that Final Four outcome column, which again was pulled from Wikipedia on the history of all the NCAA tournaments and whether or not that team made it to the Final Four. Okay, so with that said, we go ahead and in this line 16 here, we create that target column in the data. Then I do some additional checking of the data. So in this next 3-line code set, I'm just looking really data exploration light. Exploratory data analysis, if you will, but it's super pared down, right? All I'm really doing is just looking to see which columns have a lot of nulls. I go through, I also create proportions. I use proportions, especially when the data is large enough, to make some decisions. Here, I pull out the bad columns, that is columns that have a proportion of missing values that is greater than 30%. I get those in a list and I drop them from the data frame. We don't need those. They're ugly. All right, so we move on. Then I impute the values on the remaining columns that do have some missing data. And all I'm doing here is just a very straightforward mean imputation, which happens on lines 31 to 33. So I iterate over each column, and I just simply impute the mean for all the missing values in those columns. Okay, then the final set is to create a list of those columns, and then I create my training data set, which is now all numbers, all columns with numeric fields, and I make sure that Pandas is actually interpreting them as numbers by just saying as type float. Give me all floats, right? Those are numbers that have decimal places. And we need that because there are some numbers in there, like percentages and whatnot, that we want to maintain decimal places for accuracy. Okay, so that is the cleaning light code that I went through to get the data into a machine readable format. The next step is to train the model. All right, so as I had mentioned, what I'm using in this particular code set is XGBoost. A boosted model is a model that tries to learn from its mistakes at a very high level. Conceptually, that's what it's doing. So we have a binary classification problem. We're going to apply an XG boosted model to our historical data to try and associate the season statistics with whether or not that team would make it to the Final Four for that year. Okay, so I create my training columns, right, which is just all of the data that I'm going to use for just training, right? So we want to remove the outcome column, right? You don't want to include the outcome column in your actual model that you're training because, well, then it would be 100% correct. We'll actually come back to that. And then I have a separate Y here, which is my outcome, right? So this is just the single column that represents the zeros and ones that help me identify whether or not a particular team went to the Final Four for that year. Create my train test splits. Move on down. Here's my model. Super simple, not even really adding any kind of manipulation over the hyperparameters. So all of that stuff is just default. Hey, this is for fun, right? So then I go ahead and fit the model to the training data with the training outcomes, and I generate a accuracy score. I went ahead and generated it on the whole thing. I didn't generate it just on the test side, which is typically what you should do. I was just curious, how does the model do for all the data? And it turns out that my model, let me go to it. Let me show you. Where's my accuracy score? There it is. Okay, accuracy score 0.9815. Who is the data science monster right here? Yeah, 98% accuracy. What? My model is 90% accurate? Okay, this is where we realize that there is bias in the data. Okay, there's bias in the data. I knew this ahead of time. I have another friend who's working on this, and he made me aware of this as well. But the season data that we have for the historical seasons for each team includes in that season data, in those statistics, the outcomes of whether or not they won the NCAA tournament. So what that means ultimately is that there is indicators in our data that essentially could bias the prediction that won't be available whenever we go score the model on today's data. This means the model is going to overemphasize the importance of the totals columns, like the column for total number of wins in a given season, because obviously those who won the tournament will have more wins for that season. Now, different teams play different amounts of games, so it's not a huge, sort of problem, although it turns out it is a big problem, right? But it's something to keep aware of, right? So do we get rid of those totals? There's different ways to manage that. But at this point, I'm sort of saying, well, I don't care that that bias is in the model. I still have the data available for this season, the same elements, even though not quite as complete. So I'm going to just say, given the same elements, can we still kind of predict who is going to win this year? Okay, so with that said, in this score section, I go ahead and score my model on the data for the 2022 season, which requires a little cleaning. If you look at that data set, scroll down, you'll see some of the rows actually should look like column headers. We need to get rid of those. And so I do that here in these two lines. Then I go ahead and build my prediction. So here, drum roll please. This is the output of our efforts. Here are my predictions for the winner of the 2022 NCAA tournament. Who's going to the Final Four? Let me pop up my results. I'm going to scroll on over to my predicted column. Okay, this is my predicted column, the predicted probability that any one team in this data set would win the go to the Final Four, the NCAA tournament. I'm going to sort on this from largest to smallest. And so we see the top team has an 87% chance of going to the Final Four. I'm also going to call them my top likely to probably win from the model's perspective, but that's not my pick. It's not my pick. So look, we have 3 teams that are all predicted above 40% to be in the Final Four. Everyone else is pretty low, and there's almost a tie here between the 4th and 5th teams. Let me scroll back over to the left and let's see what those teams are. Those teams are. So here are my picks for the Final Four. Gonzaga, Kansas, Kentucky, and Murray State. Okay, those are my picks. Now, I'm already wrong on one of them. Kentucky lost in an upset to St. Peter's last night. Okay, good thing I built this before. All right, so I've already lost on Kentucky. And actually, a friend of mine who I mentioned is building a model. He didn't even have Kentucky in his model, so he's already doing better than I am. We'll learn more about what he did. But I am not picking Gonzaga to win the whole thing or Kansas. I am picking Murray State in an upset to take the NCAA tournament. And here's why. My model's a low prediction, but it's still in the top four. Moreover, Murray State has the strongest win record for all the teams in the NCAA tournament. Now, granted, their schedule isn't as hard as Gonzaga's is or Kansas's is, but the underdog matters in this tournament. Baylor, look at Baylor from last year. All right, so that is who I'm predicting to take it all this year. You also can see my top 10 based on the model. Hope your team is in there. I've got some Arizona fans. I've got some Tennessee fans that I'm friends with. So good luck to everybody. And you heard it here first. Murray State for the win. All right. Good luck, everybody.